So naming and structures, we also call that as a nomenclature. First, we will start with a straight chain hydrocarbon like straight chain alkane. So for a straight chain alkane, uh, in exam, you may have any kind of formula, like you may have a displayed formula, or it can be a skeletal formula. It can be any kind of formula. So example, if it's a straight chain and skeletal formula is given. So for straight chain, we check the number of the carbon. We use a prefix for that. And we will, for single bond, we'll use suffix ane. So how many carbon atoms are there in this compound? This is a straight chain alkane. How many and this is a skeletal formula. So how many carbon atoms are there? So 4 carbon atoms. For 4, what is the prefix we use? So we use but for 4, and because it is having a single bond, we call that as butane. So actually, this is a structure of butane. The reason why I drew the skeletal formula, not the displayed or the structural formula, because in exam you may have displayed formula, structural formula, or skeletal formula. Any kind of formula, so you should be able to name accordingly. Another example, we are doing examples of straight chain hydrocarbon, straight chain alkane. How many carbon atoms are there? So you can see 1, 2, 3, 4, 1, 2, 3, 4, and 5. So 5 we'll use pent, and they have a single bond. So we will say it is actually pentane. How many carbon atoms in this skeletal formula? So there are 6 carbon atoms. That's why we call this as hex, because of 6, and ane because they have a single bond. So this is how we name the straight chain hydrocarbon, straight chain alkane. But for branched alkanes, the rule is select the longest carbon chain, the numbering on the carbon chain starts from nearest branch. Then first name the branch. And the branch should always have YL. Then position, first the position of the branch. Then name the branch. The branch should have YL and then the chain. And the chain should have A and E. So I'm drawing the skeletal formula because in exam you mostly skeletal formulas are there when you're naming the structure. So this is a structure given to you. First select the longest carbon chain. That's the first thing. So if I select 1, 2, 3, 4. So I can select this as my longest carbon chain. This is one chain, or 1, 2, 3. This is another chain, because from one end to another, that's called one chain. But that's not the longest. This is a chain, but that's not the longest. Or 1, 2, 3, 4. So this is also the longest chain from one end to another. So first thing, I can select any. You can see when I select in this manner, I was having 4 carbon in my longest chain. When I select other way around, I'm also having 4 carbon. So it shows that the number of the carbon are same. So it does not make difference to the structure. So I select the longest carbon chain. And the name will be same. It will not make the difference to the name as well. I can select this as my chain as the second. So both cases I have 4 carbon atoms. So it will not make difference. I selected this chain. Then what we have to do, select the longest carbon chain, number the longest carbon chain from the nearest branch. So we should number the carbon atoms, but from nearest branch. So this is 1. If I number this 1, 2, 3, 4. So branch is coming at 3 if I number from right hand side. When I number from left hand side, 1, 2, 3, 4. So which numbering I should follow, left to right or right to left? When I number from left to right, the branch is coming at 2. When I number from right to left, the branch is coming at third position. So which numbering I should follow, from left to right or right to left? Because only one way we can follow. So it is from left to right because the branch is coming at 2. And this one is a branch. How many carbon atoms are there in the branch? How many carbon atoms are there in the branch? So only one carbon, you can see this carbon is there, that's outside the chain. So only one carbon in the branch. So one carbon is there, that's why we, and what is the position of the branch? Second position, we have a branch. So we write 2, that's the position of the branch. So 2 is the position of the branch. How many carbon atoms in the branch? One carbon atom in the branch, that's why we call meth. And because it's a branch, so it will be alkyl or YL will be there, methyl. Whenever there's a branch, the suffix should be YL. So 2-methyl. And how many carbon in the chain? 4. So it is 4 means but, and they have a single bond N. So actually this compound is 2-methyl meth, because one carbon in the branch, and YL it's a branch. And but because of 4 carbon, and N because they have a single bond. So this formula, the name of this compound is 2-methyl butane. Is it clear, this example? 2-methyl butane. 2 is the position of a branch. Meth is because there is one carbon in the branch, that's why it's meth. Whenever there's a branch, we call YL, and then the main chain, because 4 carbon in the main chain. How we'll know that the carbon-carbon double bond is there? So if there's a carbon-carbon double bond, then there will be 2 lines like this. If there's a triple bond, then there will be 3 lines. But because already I mentioned in the beginning, we will do the skeletal formula for alkenes as well. But right now we are doing alkane. That's why I did not draw the skeletal formula for alkene. But if there is a double bond, then how it will be a double bond? It will be in this manner. Is it clear? This first example, the skeletal formula, sorry, the naming of a branch hydrocarbon, such as branch alkane. We are discussing branch alkanes. Example, another compound. Now, first what we have to do, we have to select the longest chain. So 1, 2, 3, 4, 5. 1, 2, 3, 4. So this is the longest chain. This is the longest chain. The numbering should start from nearest. We'll number the longest carbon chain, and the numbering of the longest carbon chain should start from nearest branch. So if I number from right to left, the branch is coming at 3. If I number from left to right, the branch is also coming at 3. So it does not make difference when both ways the branch is coming at same position. How many carbon atoms in the branch? How many carbon atoms in the branch? Carbon atom in a branch. This is what is coming outside is a branch. So it's 1. And what's the position? So it's third position. So we'll say 3. Meth because 1 carbon. YL meth because 1 carbon. YL due to branch. And they have throughout the chain 1, 2, 3, 4, 5. So it will be pent and single bond in. So it is 3-methyl pentane. Is it clear, the structure? Another. So this is a structure, the skeletal formula, and you want to name this. Again, we select the longest 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5. So you can see 1, 2, 3, 4, 5, 6. So actually this is the how to do this. Like first mark the ends, like you mark end A, B and C and count from one end to another. When I count from A to B, how many carbon were there? 1, 2, 3, 4. When I count A to B or B to A, it does not make difference. But when I count from A to C, 1, 2, 3, 4, 5, 6. When I count from B to C, 1, 2, 3, 4, 5. So which one is the longest chain? From A to C is the longest chain. So when I select this, this is the longest chain. Then numbering should start from nearest. So if I number 1, 2, 3. If I number from other way around, it will be 1, 2, 3, 4. So which numbering I should follow? The first one because it's coming at 3. How many carbon are there in the branch? This is a branch. What is outside is a branch. How many carbon atoms in the branch? This is only one carbon is there, not two. This part is a branch, what I circled here. That's a part of the main chain. This is not the branch. Only one end is there, so means that end shows a carbon. So it's having only one. So it's third position. We have a branch which is having one carbon. So it is 3-methyl. 1, 2, 3, 4, 5, 6. So for 6, it is hex and single bond in. So this compound is 3-methyl hexane. Is it clear? This is structure. 3-methyl hexane. Is it clear? The structure, the naming nomenclature using a skeletal formula. Any doubt in this? Yes, after selecting the longest carbon chain, the part which is left is called a branch. Now you have to name this. First thing, look, best thing to do is mark the ends. Like this is A, B, C. So when I count from A to B, how many are there? 1, 2, 3, 4. From A to B, there are 4 carbon atoms. Because first I have to select the longest chain. From B to C, 1, 2, 3, 4, 5. From A to C, 1, 2, 3, 4, 5, 6. So 6 are there. So which one I should select? That's from A to C. So the part which I select, that's the longest carbon chain from A to C. And what I'm, sorry, the from A to C, this is the longest carbon chain. And what we are left with, that's a branch. So when I count, like if I count 1, 2, 3, 4, 5, 6. So if I count from left hand side, if I count from left hand side, the branch is with the third carbon. But if I count from right hand side, 1, 2, 3, 4, 5, 6. So branch is coming at 4th. So I should follow the numbering from left to right because the branch is coming at the third carbon. So what is the name of this compound? What is left, what we are left with is a branch. So this part is a branch which is having only one carbon. So third position we have a branch. So we'll say 3-methyl hex because an N. So actually it's the same structure as the previous one. So in a skeletal formula, sometime it looked different, but it is same structure as we drew before. Is it clear, this structure? The naming of branch hydrocarbon, branch alkane. Now I want everyone present to answer these questions. The name. This will be branch. Because what's the name of this compound? Yeah, what's the name of this compound? It's 2-methyl propane. That's correct. Because you selected the longest carbon chain. So, and you number 1, 2, 3. Both ways it was, if I select this also longest, both are the 3. This is a branch of 2-methyl propane. If we have identical branch, if 2 identical branches are there, we'll use the word di. If 3 identical branches are there, then we'll use the word tri. And if 4 identical branches are there, then we'll use the term tetra. Another example, I want everyone to answer this structure. What is the name of this compound? Yeah, what's the name of this compound? Select the longest carbon chain. Two identical branches. Look, when we select the longest carbon chain, 1, 2, and 3. So what we are left with is a branch. So one carbon up, one carbon down. So but identical branches are there. So we call that as 2, 2. If two branches, so twice we have to use a number. This 2 is not because it's like two branches. This 2 is the position of the branch. For 2, 2 dimethyl, because two methyl branches are there, so that's why we call dimethyl. And 3 carbon, so we'll say prop and single bond N. So it is 2, 2 dimethyl propane. Is it clear? This example, 2, 2 dimethyl propane, the structure. Another example, if I count from left to right, the branch will come at second. If I count from right to left, the branch will also come at second. Only one numbering I can follow if both branches are coming at the same place. So I have second position, I have branch, and third position, I have branch. And identical carbon atoms, like 1, 1 carbon atom. So I will say 2, 3 dimethyl and 4 carbon, it will be but and single bond in. Why? Because when I count from left to right, so branch, the first branch was coming at second carbon. When I count from right to left, the first branch is coming with the second carbon. So both, if we count, like we have two branches, but the nearest branch is coming at the same place, so we can count from any side. Now, what's the name of this compound? What's the name of this compound? Two, 3 dimethyl pentane. That's correct. 2, 3 dimethyl pentane. Because second position we have branch, third position we have branch, and two identical are there, so that's why it's methyl pent, because 1, 2, 3, 4, 5 carbon. Now what's the name of this compound? What is the name of this compound? I want participation from everyone so that it shows your understanding. Yeah, what's the name of this compound? You will select the longest carbon chain. Numbering should start from nearest. No, it's not. When you count this, look, 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6. So both ways I counted. Now, how many carbon atoms in the branch? 2 carbon, 1 and 2. So if 2 carbon atoms in the branch, then this compound is 3-ethyl. Eth because there are 2 carbon, and YL because it's a branch, and 1, 2, 3, 4, 5, 6. So it will be hexane. So it is 3-ethyl hexane. Why ethyl? Because there are 2 carbon atoms in the branch. Is it clear? This structure? So we started organic chemistry introduction. We did alkane, branched, as well as straight chain. Now the third type of alkane is cyclic alkane. Cyclic alkane means that there is no end. So if I want to draw even a skeletal formula, so there is no end. How many carbon atoms are there? 1, 2, 3. So if 3 carbon atoms are there, so we'll say prop and single bond end. But how we'll know it's a cyclic? So we will just use the term cyclo. So it is cyclopropane. Is it clear? What is the name of this compound? What is the name of this compound? No, the cyclic is not ending at YNE. Alkyne, when carbon-carbon triple bond is there, that is ending at YNE. The cyclic alkane also end at ANE. ANE shows that there is a single bond. So cyclo, because there is no N, so it is cyclo hexane. It is ine YNE if there is a triple bond, but we are only discussing alkane, straight chain, branched, and now the cyclic. What's the name of this compound? What is the name of this compound? So it's cyclobutane. Is it clear? So today we discuss the nomenclature of alkanes. Next class we will discuss alkene, alcohols, carboxylic acid, carboxylic acids, and halogen alkanes, esters, aldehyde, and ketone. We'll discuss all of them. Any doubt related to the class? Okay, so I'll end session and share the recording with you.